The higher a ball is raised, the more potential energy it has. Hence, it will sink deeper into the sand bed. The candle had potential energy. When the candle burned, its potential energy was converted to heat energy and light energy, thus the temperature of the setup increased. Using a weight of greater mass and raising it to a greater height will increase its potential energy. Since energy is converted from one form to another with more potential energy, the weight will have more kinetic energy. An object that is higher above the ground has more potential energy than an object that is lower in position. When the objects are released, their potential energy is converted to kinetic energy. Thus, the object with the lowest amount of potential energy will reach the ground with the lowest speed. Container D had more water than container A, so the water in it took a longer time to boil. Container B had more water than container C, so the water in it took a longer time to boil. Container D had more water and had a lower temperature at the start of the experiment, so it would use the most amount of energy to bring the water to boil. The water in all the containers would take a shorter time to boil if the glass containers were replaced with metal containers. Metal is a good conductor of heat. Thus, heat will be conducted to the water more quickly. Releasing the toy car from a lower height will cause its potential energy to decrease. When distance is increased, the toy car has to travel over a greater distance before hitting the gong. A carpet will greatly increase the friction between the tires and the ground, thus reducing the speed of the toy car. Therefore, the sound from the gong will decrease in loudness. The toy car was stationary before it was released. Its potential energy was converted to kinetic energy as it moved down the ramp. When it hit the gong, it stopped. The kinetic energy was converted to sound energy. When the switch was closed, the fan started to turn and the bulb lit up. When the switch was closed, an electric current flowed through the wires. At the fan, electrical energy was converted to kinetic energy. At the bulb, electrical energy was converted to heat energy and light energy. The manual hand drill converts potential energy to kinetic energy, sound energy, and heat energy. The electric hand drill converts electrical energy to kinetic energy, sound energy, and heat energy. The electric hand drill uses electrical energy, while the manual hand drill uses the potential energy of the user. The motor boat gets its energy from the fuel in its tank to move in the water. It is unlikely to be powered by the water since it is moving upstream. If the motor boat moves downstream, it is powered by both the moving water and the fuel in its tank. Thus, the amount of fuel used will decrease assuming that the speed of the boat remains the same. Jenny will have the most potential energy at point A. She is at the highest point above the ground. Jenny reaches point C before going back to point B again. Point C is not as high as point B because not all the potential energy at point is converted to kinetic energy to reach point C, some energy is converted to sound energy and heat energy. Rovi gets the energy from the food he eats to pull the elastic band. In order to hit an object at a further distance away, Rovi should stretch the elastic band of the catapult further. When the elastic band is stretched further, it will have more potential energy, enabling the stone to go further upon release. If Don uses more energy to bounce the ball would bounce higher and for a longer period. The height that the ball bounced decrease after each bounce because some energy was lost to the surroundings, sound energy and heat energy. The 3 hot stones are heated over a flame before they are put into the water. The aim of the experiment is to find out the effects of the hot stones on the temperature of the water in the beaker. There is a change in temperature of the water because the water gains heat from the hot stones, causing the temperature of the water to rise. To cook the shrimps and vegetables faster using hot stones, put more hot stones into the container. With more hot stones, more heat energy is supplied to the water, raising the temperature of the water more quickly. Alternatively, put less water in the container. If there is less water, the temperature of the water will rise more quickly when the same amount of heat energy is supplied. The energy conversion that will take place when Helen hits each glass gently with a metal spoon is potential energy to kinetic energy to sound energy. To produce a louder sound, Helen must hit the glasses harder. More potential energy will be converted to kinetic energy, which will be converted to sound energy. Orin can reach the 4th level of her apartment from the 1st floor by climbing a flight of stairs or by using the elevator. She gains an equal amount of gravitational potential energy whether she climbs the stairs or takes the elevator. She uses more potential energy to climb the stairs than taking the elevator. As long as Orin gains height, she will gain gravitational potential energy, whether she climbs the stairs or uses the elevator. The chemical potential energy from food in Orin is converted into kinetic energy as she climbs the stairs. If Orin takes the elevator, she will not use any of her stored chemical potential energy, as the elevator uses an external source of energy to carry Orin upwards. Since ball K stretches the rubber band the most, it has the heaviest mass and thus exerts the most gravitational force. While ball K may be the heaviest ball, it is also the closest to the ground. Hence, it is not definite that it has the most gravitational potential energy. The starting point of the roller coaster track has to be the highest point so that there is sufficient gravitational potential energy that can be converted to move the car all the way to the end. As the ball falls from point P to Q, the potential energy of the ball decreases. As an object loses height, the gravitational potential energy will be converted to kinetic energy. The higher the object, the more gravitational potential energy it has. The lower the object, the less gravitational potential energy it has. The ball will have the same amount of gravitational potential energy at point Q and R. Since the ball is at the same height at points Q and R, the amount of gravitational potential energy will be equal. Since the action of pushing the toy is a type of movement, it will contain kinetic energy. The capacity of the cup affects the mass of water in the cup. The larger the cup, the more water can be held in the cup, which increases the mass. As point B is higher than point A, more kinetic energy would have been converted to gravitational potential energy. When the fuel burns, chemical potential energy, the flame warms the air beneath the hot air balloon, heat energy. As the hot air rises, the hot air balloon will start to float, kinetic energy, and move away from the ground, gravitational potential energy. Burning of natural gases and fossil fuels result in the release of large amounts of carbon dioxide and other greenhouse gases, which will trap more heat energy on Earth and speed up global warming. Clean energy sources such as wind, solar, moving water do not require the burning of a raw material to produce electricity. The kinetic energy decreases from D to E as the kinetic energy is converted to gravitational potential energy. Since the ball is at a lower height at point C than A, the amount of potential energy in the ball will also be lower at C than A. Book A fell 2 shelves down, while other books fell by a shelf. So, it lost the greatest amount of gravitational potential energy. Photosynthesis is the process of plants making food. Light energy from the sun gets converted to food, chemical potential energy. Potential energy decreases from P to Q as the height decreases. The gravitational force acting on the ball is the same at all heights. There has been a lot of focus on alternative sources of energy, such as the sun and the wind. The reasons behind the focus for wind and solar energies are that they are renewable sources of energy and easily available. Wind and sunlight are easily available. We cannot rely on the same source of energy which can run out one day. A ball was released from the highest point of ramp P. The ball was stopped by block R. All the kinetic energy would be converted to heat and sound energy when it hit the block. Energy would be converted from potential to kinetic energy as it is released from the ramp. The ball would have the least kinetic energy when it is at the highest point of the ramp. Kinetic energy was converted to potential energy when the ball traveled up the ramp. The girl is highest at point B. Hence, the greatest amount of gravitational potential energy can be found there. After she dived into the pool at point D, most of the gravitational potential energy has been converted to kinetic energy. Possible explanations why the brightness of the bulb was 0 when the 6th battery was added was because 1. Too many batteries were added to the circuit. 2. The wire and the 6th battery were not connected properly. A new battery should have chemical potential energy. The object at trampoline B possesses the greatest gravitational potential energy, greatest mass and greatest height. Thus, the object at trampoline B will bounce off the highest. To allow the cup to spin faster, adding more lit candles will allow the cup to spin faster, as more lit candles means more air will be heated. When the heated air rises, the kinetic energy in the air is converted into the kinetic energy in the cup. Samantha pulled the rubber band backwards together with a stone to position A. When she released the rubber band with the stone moved forward and hit the block. The block swung from position B to position C, as shown in the diagram below. The main energy conversions taking place is elastic potential energy, rubber band pulled backwards, kinetic energy, moving stone, gravitational potential energy, block moving to a higher position, kinetic energy, block moves back to position B. A block was hung on a spring. When the block was pulled downwards until it reached point A, and then released, the block rose to point B and then to point C. The graph shows how the potential energy and kinetic energy in the spring changed as it was compressed when the block moved from point to C. Rovi dropped a ball from a height above the ground. As the ball bounced, Amy noticed that the ball bounced up to a lower height after each bounce. The ball did not bounce back to the initial height from which it was dropped because some of the kinetic energy was converted to heat energy and sound energy when it hit the ground. Some of the kinetic energy was converted to heat energy and sound energy when it hit the ground. Jane released a ball from the top of a slope at P. The diagram below shows the path taken by the ball before it comes to rest at T. An object at rest has no kinetic energy. However, depending on its position, it will have a form of potential energy. Gravitational force acts on all objects at all times on Earth. There is lower kinetic energy at R than at Q, lower height increase at R. Some kinetic energy has been converted into heat energy from Q to R. There is no gravitational potential energy between S and T because there is no change in height.
Fatima left a remote-control car near the bottom of a slope as shown below. Once she pressed the forward button on her remote control, the car moved forward. She then pressed the stop button on the remote control, but the car continued to move forward and up the slope before falling to the floor. The energy conversion in the car after she pressed the forward button on her remote control is electrical energy, kinetic energy, potential energy, kinetic energy, sound plus heat energy. The diagram shows 4 objects which are hung from the ceiling. Object X has more potential energy than Object Z as it is at a greater height. Object Z has more potential energy than Object Y as gravitational potential energy depends on both mass and height. Hannah designed a doorbell as shown below. She attached the steel rod to a support so that the rod can swing freely. When the circuit is closed, she observed that the steel rod swing and hit the bell. The potential energy in the batteries is converted to electrical energy in the wires. It magnetized the iron rod, which attracts the steel rod, kinetic energy, and the steel rod hits the bell, sound energy. Energy cannot be created or destroyed. It can only be converted from one form into another. The diagram below shows a method of generating electricity for houses. Heat energy from the boiling water is converted to kinetic energy, from the moving steam is converted to kinetic energy, and the moving generator is converted to electrical energy generated for the houses.
Hansen measured the electrical energy used by a cable car as it traveled from point P to Q and then from point Q to R. From point P to Q, the cable car was moving down the slope. From point Q to R, the cable car was moving up the slope. From the graph, you can observe that the cable car uses lesser electrical energy as it travels from PQ to QR. It requires lesser energy for a cable car to move down the slope compared to up the slope. As Clark turned the handle of the dynamo torchlight quickly, the torchlight warmed up and then lighted up. Clark's hand. Potential energy and kinetic energy. Handle. Kinetic energy. Lighted bulb. Heat and light energy. The paper spiral started to spin when the candle was lit. The kinetic energy of the hot air causes the paper spiral to spin. The flame on the candle heats up the air above the flame, and the hot air rises, kinetic energy, causing the paper spiral to spin. Two identical metallic spheres, P and Q, were each hung by a string from a retort stand. Sphere P was moved to position X and released. When sphere P hit sphere Q swung up to position Y. Sphere P transferred its energy to sphere Q when it struck sphere Q at position Z. The gravitational force acting on sphere Q is the same at all heights. The amount of kinetic energy possessed by sphere Q decreased as it moved from position Z towards position Y. The amount of gravitational potential energy possessed by sphere P decreased as it moved from position X towards position Z. A group of pupils conducted an experiment to find out the braking distance of a car traveling at a certain speed on a dry road. The braking distance is the distance the car has to cover when the brakes are applied before it comes to a complete stop. Based only on the graph above, it is not possible to tell from the graph that the braking distance is not affected by the mass of the car. The car will move a longer distance to come to a stop when its speed is higher. The braking distance will increase as the kinetic energy increases. The braking of the car will convert kinetic energy into heat and sound energy. The diagram below shows a ball being dropped from P. It reached the ground, Q, and then bounced to R. The ball bounced a few times before it came to a stop. There is gravitational force acting at position Q. From Q to R, the kinetic energy of the ball decreases. Just before reaching Q, the ball has the highest amount of kinetic energy. At R, the ball has less gravitational potential energy compared to when it is at P. The water garden feature below is solar-powered. The solar panel, which absorbs energy from the sun, is connected to a motor in the bowl. The motor pumps water up into the jug through the water pipe. Then the water flows down to the bowls. A solar panel relies on light energy. The garden feature cannot operate when there is no light energy. The water in the big bowl is at a lower height compared to the jug, thus it has less potential energy. The water flowing out of the jug has both potential energy and kinetic energy. Light energy is converted to potential energy and kinetic energy for the feature to work. Adam dropped a slab of concrete to push a nail into a piece of wood, as shown in the diagram below. D is the distance between the concrete and the nail at first. The slab of concrete pushed the nail into the wood. He then measured the distance x between the top of the nail and the surface of the wood. The distance d affects the distance x. The shorter the distance d, the lesser the gravitational potential energy. Thus, distance x will be longer. The bigger the mass of the slab of concrete, the shorter the distance x. When the mass of the slab of concrete increases, distance x decreases.
Timothy held a toy between his hands, as shown below. At A, he rotated the toy by sliding his right hand forward and left hand backward before releasing it. The toy flew from A to B and then to C before falling to the ground. The energy of the toy at A, B and C. A potential and kinetic energy. B potential and kinetic energy. C potential energy. Two marbles, A and B, were dropped from the same height. Marble has a greater mass than marble B. The following graph below correctly represents how kinetic energy changes as they move downwards before they hit the ground. Explanation: the greater the mass, the greater the kinetic energy. A wound-up toy at position P was moving forward until it stopped at position Q. The toy has more potential energy at P compared to Q. The toy stopped at Q as the car has used up all its kinetic energy, but still has potential energy while it is at rest at point Q. A solar panel converts light energy into electrical energy. One advantage of using solar energy is that it is a renewable energy source. It can be harnessed in all areas around the world. We cannot run out of solar energy, unlike some of the other sources of energy. However, solar panels take up a lot of space. The more electricity you want to produce, the more solar panels you will need to install. Cheng Yi can reach the 5th level of his apartment from the 1st floor by climbing a flight of stairs or by using the elevator. The gravitational potential energy he gained from climbing the stairs is the same as when he is using the elevator. B. The amount of gravitational potential energy he gained is based on the height. Explanation. The higher an object is located, the more gravitational potential energy it possesses. Mei Ling swings a water bottle to point P and then swings the bottle to point Q and tosses it. The bottle reaches maximum height at point R and flips. It comes to a stop at point S. There is an equal amount of gravitational force acting on the bottle at all times. The bottle at R possesses greater potential energy than at P, as it is higher above ground. The amount of kinetic energy is decreasing from Q to R. A block of wood slid down a smooth glass after it was released at the top as shown in the diagram below. The graph shows the amount of different types of energy of the block at midpoint P. The experiment was repeated on a slope covered with a sheet of sandpaper. The following graph correctly shows the amounts of different types of energy at P. Explanation. When sandpaper is placed on the surface of the slope, the box will encounter more friction, more heat energy, and it will move at a slower speed, lower kinetic energy. However, the gravitational potential energy will remain unchanged, dependent on height, and height of P did not change.
Which is the source of energy that enables the windmill to spin? The sun. The solar-powered fan gets its energy from the sun. When the fan turns, the windmill will then spin. As water from trough flows down to trough B, it turns a water wheel, which is connected to a dynamo. The bulb lights up after some time. Where does the bulb get its energy from? The dynamo. The dynamo converts kinetic energy to electrical energy. What is the energy conversion in the setup? Potential energy of water in trough A to kinetic energy of water wheel to electrical energy to light energy. As the water flows down from trough A, the potential energy of the water is converted to kinetic energy. The moving water turns the water wheel, and the kinetic energy of the water wheel is converted to electrical energy by the dynamo. The dynamo supplies the bulb with electrical energy to light up. What changes can be made to make the water wheel turn faster? Raising trough higher will increase the potential energy of the water in trough A. Thus, the water from trough will hit the water wheel with more kinetic energy, causing the water wheel to turn faster. A battery-powered toy car is attached to a rod by a stick. One end of a spring is attached to the rod, while the other end is stuck to the floor. When the toy car moves forward, it wins the spring. Which form of energy is stored in the battery in the toy car? Energy is stored in the battery in the form of potential energy. What is the purpose of the stick in the above setup? It is to ensure that the toy car moves in a circular motion and wins the spring as it moves. The stick ensures that the toy car does not stray away. It helps to convert kinetic energy to potential energy. The toy car is turned off. The spring starts to unwind and causes the toy car to move in the opposite direction. What is the energy conversion? Potential energy. 2. Kinetic energy plus sound energy. As the spring unwinds, the toy car starts to move. Sound is produced as the toy car travels on the board. 2 beakers of water were heated as shown below. The temperature and amount of water in the beakers were the same at the start of the experiment. When the liquefied petroleum gas was burned, heat energy was given off. When more heat energy is supplied, water is able to change from liquid state to gaseous state at a faster rate. Without the windmill, the boat was still able to move at a slower speed. This implies that energy from moving water was moving the boat too. With 2 windmills and 2 propellers, the kinetic energy supplied to the boat would increase, causing it to move faster. The plant gets its energy from the light energy of the sun when making food. The eagle gets its energy from both the rabbit and the rat. The sun provides the heat energy to heat up the water, soda can, box and clear glass cover. There is more water in the 660 ml soda can, but the heat source remains the same, so it will take a longer time to heat up the water. The source of energy that can power the solar calculator is the sun. The solar calculator requires light in order to function. The water was heated up by a very hot fluid inside the earth. The advantage of using heat from the hot spring, as it is a source of energy that will not run out. The jet of water gets closer to the container as time passes. There will be less water left in the container over time, leading to a decrease in the height of the water column. Hence, the jet of water that shoots out from the hole has less kinetic energy and gets nearer to its container. In a hydroelectric power station, water flows through the dam when the gates are opened. The moving water turns the turbines as it flows to the other side of the dam. What energy does the water behind the dam have? The water behind the dam has potential energy. Why are the gates open only when a lot of water has been collected behind the dam? With more water collected behind the dam, the water has more potential energy. Hence, more potential energy will be converted to kinetic energy to turn the turbines as the water flows through the dam. The source of energy for the kite in the sky is wind. The source of energy for the remote-control toy aeroplane is batteries. 2 advantages of using wind as a source of energy. Wind is a source of energy that will not run out. It does not produce greenhouse gases. A disadvantage of using wind as a source of energy. Wind may not be present at all times. Describe the difference in the way the power station and a hydroelectric power station generate electrical energy. In a power station, electrical energy is generated when fuels are burned to provide heat energy to boil the water to turn the turbines. In a hydroelectric power station, electrical energy is generated when moving water turns the turbines. One advantage of using a hydroelectric power station is that it does not produce greenhouse gases. Suggests another disadvantage. The source of energy, which is moving water, will not run out. The moving water causes the toy boat to move. Moving water is a source of energy, and as the speed of the moving water increases, the toy boat moves faster. The aim of the experiment was to test how the height of an object above the ground affects the amount of potential energy it has. Therefore, besides changing the height of the wooden blocks above the ground, all the other variables should remain constant. Energy would be transferred from the wooden blocks to the nails. The potential energy of the wooden blocks would be converted to kinetic energy. As they hit the nails, their kinetic energy would be converted to kinetic energy of the nails. Thus, the greater the potential energy that the wooden blocks had, the deeper they would drive the nails into the surface. We can conclude that the higher the object, the deeper the nail will be driven into the surface. The ball at position is stationary, so it has only potential energy. At position B, the ball is at the lowest point of the slope, so it has only kinetic energy. At position C, the ball has both kinetic energy and potential energy, as it is moving and is above the lowest point of the slope. A marble is placed in the holder of a catapult, and the elastic band is pulled hard. What will happen when the elastic band is released? The marble will shoot off and the elastic band will return to its original state. The stretched elastic band has potential energy. When the elastic band is released, the potential energy will be converted to kinetic of the marble. Where does the marble get its energy from? A stretched elastic band has potential energy. When more heat energy is supplied to the water, it will boil faster. The higher a ball is above the ground, the more potential energy it has. To find out which balls had the greatest potential energy, Gary can measure the horizontal distance the balls traveled from the foot of the ramp to where they stopped after they were released. The potential energy of the balls was converted to kinetic energy as they rolled down the ramp. The balls would eventually come to a stop. With more kinetic energy, they would be able to travel a greater horizontal distance. Hence, by measuring the horizontal distance the balls had traveled, Gary could arrange the balls according to the potential energy they had. As the ball bounced, some energy was converted to sound energy and heat energy. The maximum amount of kinetic energy the ball had decreased over time. A pipe is fitted to a pump. When the pump is switched on, the water level in the pipe starts to rise very rapidly and the ball shoots out of the pipe. Where does the pump get its energy to turn its turbine? Electricity. Electricity is a source of energy that enables some machines to do work. What energy does the ball have as it shoots out of the pipe? Kinetic energy and potential energy. The ball is moving and gaining height as it moves out of the pipe. A breeze blew during the experiment. In which direction did the breeze blow? Did it blow from left to right, or right to left of the candle? Explain your answer. The breeze blew from right to left. The air temperature between the heater and thermometer was supposed to be lower than that of the candle and thermometer, since it was further from the heat source. However, it was the same, indicating that heated air near the candle was blown towards the thermometer. What is the relationship between the distance from the heat source and the temperature of the air? As the distance from the heat source increases, the temperature of the air decreases. During a barbecue, should a raw prawn be brought nearer or further from the glowing charcoal in order to cook it faster? Explain your answer. It should be brought nearer the glowing charcoal. When the raw prawn is nearer the glowing charcoal, the temperature is higher and there is more heat energy. Hence, it will cook faster. What is the source of energy that enables the paper coil to spin? The lighted candle. What can you replace the source of energy with to create the same effect? A small oscillating, turning fan. Karen has a toy car that will move when its spring is wound. She wants to find out how the number of turns the spring is wound affects the distance the toy car can travel. What is the energy stored in the wound spring of the toy car? Potential energy. What can Karen conclude from the experiment? The more the spring is wound, the greater the distance the toy car can travel. Beyond a certain number of turns of the spring, the distance the toy car can travel does not increase. In a hot spring, the source of energy that heats up the water is heat inside the earth. In an electric kettle, the source of energy that heats up the water is electricity. Which is a more environmentally friendly method of obtaining hot water? Potential energy. Ollie designs a vehicle that is a boat resting on 4 wheels, with a sail attached to the boat. When the vehicle rolls and falls into the water, the wheels will drop off. Ollie places a long table over a drain to test his vehicle. State the source of energy that enables the vehicle to travel on the table. Wind. State the sources of energy that enable the vehicle to travel on water. Wind and moving water. How can Ollie change the design of the vehicle to allow it to travel faster? Explain your answer. Enlarge the sail. With a larger sail, the vehicle will be able to capture more kinetic energy from the wind. Which of the following actions requires the least energy? Floating on water requires the least energy, as there is very little change in potential energy. There is very little energy conversion compared to all the other actions which need more energy. The electrical energy is converted to kinetic energy of the rotating drill, which is then converted to sound and heat energy. Which of the following forms of energy are able to travel through a vacuum? Only light and heat energy can travel through a vacuum, for example, from the sun to Earth. Sound energy cannot travel through a vacuum. How is energy converted when a camera captures an image on film? Light energy. 2. Potential energy. When a film camera captures images, light energy enters the camera through the lenses and hits the film in the camera, where chemical changes occur. Light energy is converted to chemical potential energy as images are produced on the film. Which of the following contains stored elastic potential energy? A wound-up spring is compressed in a wound-up toy car, so it has elastic potential energy. A loose spring and a falling rubber ball are both not stretched or compressed, and hence do not contain elastic potential energy. Alan was swinging to and fro. How do you think his kinetic energy changed with his gravitational potential energy while swinging? When Alan swings, either kinetic energy is converted to gravitational potential energy, or gravitational potential energy is converted to kinetic energy. When gravitational potential energy increases, kinetic energy must decrease. Note, for every unit of potential energy gained, 1 unit of kinetic energy is converted. Since the rate of conversion between potential energy and kinetic energy is the same, the gradient of the graph should be constant and the graph should be a straight line. Robin Hood shot an arrow right into the bullseye of a target. State the energy conversion involved. Kinetic energy of archer, arm, to elastic potential energy of bow, to kinetic energy of arrow, 2. Heat energy plus sound energy. In reality, archers always aim slightly above the target in order to hit it, instead of aiming at it directly. Explain why this is so. While the arrow is moving through the air, its weight will pull it downwards. To hit the target, the archer needs to shoot upwards to counter the arrow's weight. The diagram shows a coal-burning power station. State the energy changes that occur in the power station. Chemical potential energy of coal. 2. Heat energy. 2. Kinetic energy of steam. 2. Kinetic energy of turbine. 2. Electrical energy. Name 2 other sources of renewable energy that can generate electricity. Wind energy. Solar energy. A boy threw a rubber ball that was initially on the ground vertically upwards into the air. When the ball reached a certain height, it stopped momentarily before falling back. Fill in the forms of energy present in the ball at the various points of the ball's journey. Gravitational potential energy. 2. Gravitational potential energy plus kinetic energy. 2. Gravitational potential energy plus kinetic energy. When the rubber ball fell to the ground, it bounced instead of stopping. Explain why this happened. When the ball hit the ground, kinetic energy was converted to elastic potential energy in the ball, so it bounced. Joe is holding a guitar. Points A and B are different parts of the string on his guitar. How is sound produced when Joel plays the guitar? The strings vibrate when they are plucked to produce sound energy. Describe the energy conversions that occur when Joel plays the guitar. Kinetic energy of Joel, arm. 2. Kinetic energy of guitar strings. 2. Sound energy. When a guitar string is plucked, The sound produced at point is different from the sound produced at point B. Explain why this is so. The sound produced is different because the strings have different lengths and tightness and hence vibrate differently. A sky lantern has a covered top and an opening at the bottom. A candle is lit, which allows hot air to rise, lifting the sky lantern in not the air. What are the energy changes when the candle is lit and the sky lantern rises up into the air? Potential energy. 2. Heat energy. 2. Kinetic energy plus potential energy. Miriam sat on a swing and moved from point A to point B to point C. After some time, the swing comes to a stop. Explain why. The swing comes to a stop as all the kinetic energy is converted to other forms of energy / heat energy and sound energy. Shaw attached a 20 cm spring to a brick and placed a toy car next to it. When Shaw pushed the toy towards the brick, the spring was compressed. When the toy car was released, the spring returned to its original length and the toy car moved forward. Shaw measured the distance the toy car traveled until it came to a stop. Based on Shaw's results, what is the relationship between the length of the compressed spring and the amount of kinetic energy the toy car has? As the length of the compressed spring increases, the amount of kinetic energy decreases. Without changing the setup or introducing other new materials, what could Shaw do to make the toy car travel further than 30 centimeters? Explain your answer. Shaw could compress the spring in the setup to ensure the length is less than 14 centimeters. A more compressed spring has more elastic potential energy that would convert it to more kinetic energy. A cart rolled down its rail and hit a stationary cart Y in front of it. As a result, the stationary cart Y was pushed a distance of 2 meters forward. Would the distance moved by cart Y be longer or shorter if cart X was fully loaded with coals? Give a reason for your answer. If cart Y was fully loaded with stones, the distance moved by cart Y would be larger or further. This is because if cart X was loaded with coals, it would have a greater mass to produce greater gravitational potential energy to be converted into greater kinetic energy to move cart Y. Explain why cart Y came to a stop after being pushed forward a distance of 2 meters. Cart Y came to a stop because all its kinetic energy had been converted to other forms of energy, such as heat and sound energy. Write out the energy change throughout the whole process. Gravitational potential energy. 2. Kinetic energy plus heat energy plus sound energy. To investigate the energy possessed by a catapult when it was stretched, Mary carried out an experiment. The distance the catapult was stretched is represented by A, and the distance traveled by the stone when released from the catapult, is represented by B. Mary repeated the experiment several times by stretching the catapult to different lengths. The result was shown in the graph. What is the relationship between the distance the catapult is stretched and the distance traveled by the stone? The more the catapult is stretched, the greater the distance traveled by the stone. Describe the energy conversion when the stretched catapult was released. Elastic potential energy of the catapult was converted to kinetic energy of the stone. Without increasing the distance the catapult is stretched, suggest one way to increase the distance traveled by the stone. Give a reason for your answer. Use a stone with a smaller mass so that more elastic potential energy would be converted to more kinetic energy to move the stone further. Nicole set up the apparatus shown below to help her tell the time of the day. When water drips from the water supply into the measuring cylinder, the float rises. When the float rises, it turns the gear, which in turn moves the hand of the clock. After comparing the time told by her clock apparatus with a digital clock's, Nicole realized that her clock is slow. Suggest one change that she can make to her apparatus to enable it to tell the correct time. Give a reason for your answer. She should change to a wider tube. When a wider tube is used, water can flow into the measuring cylinder at a faster rate. This in turn causes the float to rise faster, thereby turning the gear faster. Thus, the correct time could be told. State the energy changes that occurred in the apparatus. Gravitational potential energy, water in the water supply. 2. Kinetic energy, water droplets in mid-air. 2. Kinetic energy, float. 2. Heat energy plus sound energy plus kinetic energy, gear. 2. Kinetic energy, hand of clock. An engineer was tasked to look for the best location to build a hydroelectric power station. A hydroelectric power station produces electricity by harnessing the energy from falling or flowing water. The diagram below shows the profile of the area where the hydroelectric power station is to be built. Mark with an X on the diagram to show the best location where the hydroelectric power station can be built so that the most electricity can be produced. With reference to the above, explain why you chose to build the hydroelectric power station at that location. As the water will fall from the greatest height to point X, the water will possess the most gravitational potential energy, which is converted into the most or greatest kinetic energy. State one advantage of building the hydroelectric power station at the location that you have selected. The hydroelectric power station will produce more electrical energy. The diagram below shows the various positions of a boy when he swings from point A to point C. Why will the boy slow down and eventually stop after a while? The energy is converted to other forms of energy, like heat and sound energy. A solar panel is connected to a mini fan. The solar panel captures light to generate power for the mini fan to spin. This ability to capture light resembles a cell part of a green plant. Explain what will happen to the fan when the light intensity of the torch increases. The fan will spin faster. Write down the conversion of energy when the torch is shown onto the solar panel. Light energy from the torch. Electrical energy from the solar cells. Kinetic energy in the mini fan. Suggest one way to make the mini fan spin faster. Use more torch lights. The diagram below shows a solar panel on a cap to which a fan is attached. State the energy conversion in the solar-powered fan. Light energy. Electrical energy. Kinetic energy. Yuhan installed some solar panels on the rooftop of his house. After a few weeks, the solar panel did not generate enough electricity even on a bright, sunny day. He noticed that there were plenty of birds droppings on the rooftop. How did that affect the efficiency of the solar panel? The birds dropping block out sunlight from the solar panel, so less light energy is absorbed from the sun. The drawings show a weightlifter. The stages in weightlifting are labeled A, B, C, D, and E. Where did the weightlifter get energy from to lift the weight? Which type of energy was it? The weightlifter got his energy from the food he eats. It was chemical potential energy. State the energy conversion of the weights from stage C to stage E. Gravitational potential energy. Kinetic energy. Sound energy. Heat energy. Explain why dropping the weights at a smaller height from the ground produces a softer sound than when dropping them at a greater height from the ground. At a smaller height, the weight have less gravitational potential energy. Therefore, there is less energy available to be converted to sound energy. Less sound energy means a softer sound is being produced. The diagram below shows Karen diving into a swimming pool. As she falls, potential energy is changed into kinetic energy. Why does Karen have no kinetic energy at A? She was not moving. The table shows Karen's potential energy and kinetic energy at 4 stages of the dive. As Karen falls, there is no loss of energy to the air. How do the energy values for stages A, B, C, and D shows this? Total energy at each stage is the same. Energy cannot be created or destroyed. Study the electric circuit below. When Amira closed the switch, the bulb lit up and the bell rang. What energy conversion took place when Amira closed the switch? Potential energy, batteries. 2. Electrical energy, circuit. 2. Sound energy, bell. 2. Light energy, bulb. Barry conducted an experiment shown below. He pulled the rubber band and stone backwards before releasing them. He then measured the distance x traveled by the stone. What energy conversion took place in Barry's experiment? Potential energy. Rubber band. 2. Kinetic energy. Stone. Barry repeated the experiment above by pulling the rubber band and stone further backwards before releasing them. How would the distance x traveled by the stone change? How did the increase in stretch affect the potential energy of the rubber band and kinetic energy of the stone? When the stone was released, it traveled a longer distance on the table. This is because more potential energy was converted to more kinetic energy. Clarissa carried out an experiment as shown below. She released a box from position A. The box traveled down the plank and stopped at position X. If Clarissa wanted the box to stop at position Y, what are the two changes she could make? Use a plank with a smoother surface. If a smoother surface is used, there would be less frictional force between the box and the plank. Hence, the box would travel further. Increase the height of the wooden block. If the height of the wooden block is increased, the box would be at a higher position. Hence, the box would have more potential energy. More potential energy would be converted to more kinetic energy, allowing the box to travel further. Ella held a ball and released it from position A, as shown in the diagram below. Which position, B or C, would the ball reach before moving back? Explain Ella's observations. Which form of energy did the ball have when it was at a distance from the ground? What would the energy be converted to as it moved through the air? The ball reached position B before moving back. This is because some of the potential energy of the ball has been converted to kinetic energy.